Welcome. You are welcome to my presentation. This Emertxe Embedded System Internship presentation. Emertxe is actually the organization, the institution that organized this internship. In my presentation, the first unit tackles the introduction to the internship. We have the introduction, the overview, development of embedded system. Then we will go to the C programming, the conditional constructs, the pointers, the functions also. Then we will go to embedded system programming, the embedded system structure. We will tackle the microcontroller structure, then fixing that. Then fourth unit will tackle the peripherals of a microcontroller. We have the LED, the digital keepers, timers, and the CLCD, that is the character liquid crystal display. Introduction, we have Emertxe. Emertxe is an Indian training institute that specializes in providing skill development programs in the field of embedded system and IoT, that is Internet of Things. They offer training and courses designed to equip students and professionals with the necessary skills and knowledge to work in the embedded system industry. Goal of this internship was the implementation of the programming in embedded C in the realization of our project, which was eventually the microwave. So we have the general overview of the internship. Our internship covers, in the beginning, the SDLC, that is the software development lifecycle, in which we started with the planning of our internship, actually the development of our project. So software development lifecycle is a systematic process used by tech companies and software developers to plan, design, build, test, deploy, and maintain software applications or systems. It provides a structured framework for managing the entire software development process from inception to completion. Here we have the stages. So you have to specify the requirements for your project as the development of your software. Then the design starts. You go to the implementation, then you test your project after you have implemented it. So after that, we delved into the actual software development. Then we went to the C programming. We have also tackled the microcontroller programming. So in each of these, we had quiz after each session. So after that, we tackled the implementation of our projects with the use of our simulator. Then after that, we had some workshops which were concerning the building of an impressive resume, impressive CV. So here we come with the presentation of our internship. Then after that, after the presentation is approved by the jury, we have our certificates. So what is embedded system? Embedded system is the combination of software and hardware to perform a specific task. So in this current world, we have many applications of embedded system. Embedded system can be applied in the automobile industry. We have the engine control units, the airbags. We can talk about the seat belts and many, many other things, the navigation systems. Yeah, then we have the application of embedded system in smart cities. We have in a smart city, actually, we have traffic lights and other parking systems. We have weather monitors, speed monitors, toll booths. So embedded system can also be found in the healthcare industry. We can talk about temperature measuring devices. We can talk about pressure measuring devices, then weighing machines and other stuffs. Then we have also household appliances, which are all as a result of embedded system. We have the smart TV. We can talk about the smart fridge. Then we can talk also about the Wi-Fi router and many other devices. So in the development of an embedded system, we have two main aspects. We have the hardware design, then we have the software development. In the hardware design, first you have to get your schema right. Your block design should be right. Then after that, you simulate it. You can use PCB prototype, you simulate, or you can use also breadboard. Then after that one, you design the actual circuit, which we didn't delve much into it during this internship. Then in the software development aspects, you tackle the SDLC, that is the software development lifecycle. Very, very important, because in this framework, it helps you to meet your deadline. It also helps normally for the tech companies to win more clients and also to optimize profits as you win more clients, you also win the market. That normally that's how the market goes. So in our software development lifecycle, the first aspect, that is planning and the project specification of requirements. We had C programming as our preferred language for our projects. Why did we choose C programming? We have these key features. The C language is a free formatted language, meaning it can be converted from a low-level language to a high-level language. It is also a general purpose language, which means it can be implemented in many, many, many domains. We also have the high efficiency of the C language. It is very fast and also store less. It uses less memory. It is also rich in library facilities, as it is used to be implemented in many fields. So for a typical C code, we have the documentation, the pre-processor statement, the global declaration, the main code. We have in the main code, the local declarations, the program statements, then the function calls. Then after that, we can get the functions. We write the functions, then you will have the function body. So to write a good C code, you have to know the various types of data, the data types. The data types is divided into two. We have the integral, then the floating point. The integral, we have the character, then we have the int. The character is written as char, then we have the int for the integers. Then the floating point, we have the float, then we have the double. Modifiers are used to determine the size, to specify the size or the signness, the sign of a data type. So normally, for the size aspect, we have the short, long, long, long. Then the sideness, we have the sign and unsigned. Normally, we write this, then it is followed by the data type. And we have the qualifiers. Qualifiers, we have the constant, then the volatile. So for a C program, conditional constructs, we have two main types. We have the single iteration, then we have the multi-iteration. For the single iteration, we have the if and else family, where we can find the if block, where after a condition in the if block is satisfied, the instruction under it is executed. Other than that, we also have the if else. In the if else, the instruction under the if condition, if it is satisfied, it is the condition under the if block, if it is satisfied, the instruction under it is executed. Else, if the condition is not satisfied, then we pass to the instructions under the else block. Then we also have another kind, which is the if else if. In the if else if block, we have the if block. If the if condition is satisfied, then the instruction under the if block is executed. Other than that, the else if condition is tested, and if it is satisfied, then the instructions under it is executed. Other than that, we have the else followed normally. Then if an else block is not followed, then the control will continue to another instructions that follow. Then we have the switch case. The switch case is a special case, which sometimes normally they say it is like another kind of if else. Normally, the switch case is only limited to integer variables. It is limited to integer variables. Normally, an instructions under each case is terminated by the jump statement break, so that it will get the control out if the case is satisfied and the instructions under it is being executed. Immediately after it, then the control will jump out of the loop of the switch block. So that's that for single iteration. Then for conditional constructs, for the multi-iteration, we have the for, the while, and the do while. For the while statement, it is also called the entry control loop. It is only executed the instructions when the control has tested the condition and the condition is satisfied. So that's why we call it entry control loop. Normally, after every iteration, before every iteration, actually, the condition is being evaluated. Then after that, if it is satisfied, then the iteration continues. For a do while loop, we call it exit control loop. The instruction is first executed, then the condition is being evaluated. If it is satisfied, then the next iteration will continue. If not, then the control will jump out of the loop. Then we have the for loop. In the for loop, we are talking about a loop similar to the while loop, only if the number of iterations are known. For the while loop, the number of iterations are normally not known. So we have the operators. The operators are symbols that instruct the compiler to perform specific arithmetic and logical operation on operands. All C operators do operate on the operands and return value. We have the bitwise operators. Then we have the ternary operators. We also have another operator, which is called the size of. You can see a ternary operator here. So we have the pointers and arrays. An array is a collection of a data which has the same data types. We have the array having their elements as sequential. The first element usually has the lowest address. Then the last element of the array usually has the highest address. We have pointers. Pointers are variables used to store address of another variable. Pointers are used to convert C programming from low-level language to a high-level language. Pointers helps in the returning of multiple values from a function. It helps in the parameter passing mechanism in function by passing the reference. So the declaration of pointer, we have the data type followed by star, then we have the pointer name, then semicolon. Referencing and dereferencing, these are the actions performed on a pointer. So referencing, we have this used to store the address of a variable to a pointer. Then we have the dereferencing used to extract a value stored in a pointer. So we come to the advantages. In the advantages of a function, we are talking about the reutilization of functions. Normally, they are stored in library and it can be used and reused multiple times. We have the segmentation. Functions helps in segmenting, dividing a complex block into simpler segments. It helps to make instructions clear, then also make it organized. It makes the program very clear. Then we have the testing and debugging. Dividing programs into functions helps in testing and debugging, making it very, very simpler. So to declare a function and write a function, we have to write the return data type. We have the function name, then the arguments, then the function body being written in a curly brackets. We have strings. Strings is a continuous sequence of characters, and they easily store ASCII and its extensions. So at the end of every string is marked with a special character, the null character, which is a backward slash and 0 in an inverted comma or quotation mark. So these are the various types of declaration of a string. So this leads us to our next unit, that's embedded system programming. System software. So we have the software, embedded system software, we have the actuators, and we have the sensors. We have also the auxiliary system, that is normally power, cooling, and other stuffs. We have also the human interfaces, normally the LED. Then we have the diagnostic ports. We have FPGA, ASIC, memory. Then we have DAC. DAC is the digital analog converter, which is used to convert signals from the microcontroller or the microprocessor to the actuators. The actuators respond to the signals of the microcontroller. Then we have the memory. In the memory, we can talk about three types. We have the ROM, the RAM, and the hybrid memory. We have the PROM, the programmable ROM, then the erasable ROM, the masked ROM. Then for the RAM, we have the DRAM, the dynamic RAM, then the SRAM, the static RAM. In the hybrid RAM, we have the EEPROM, and we have the flash memory, which is divided into the non-flash and the non-flash. An integrated circuit which is able to be an integrated circuit which is capable of being programmed to perform a specific task is the microcontroller. The microcontroller has many segments. We have the timers, the ports, the ROM, the CPU, the RAM, the peripherals. PIC 16F877A is our microcontroller, and we have these peripherals: CLCD, the matrix keypad, the SSDS, the digital keyboard, the buzzer, the LESS, the RS232, the GPIO, the I2C, the EEPROM, or the RTC, LM35 temp sensor. So the PIC SimLab is our microcontroller, and that's what we are going to use in the simulation of our projects. The LED, the digital keypad, the interrupts, the timers, the clock, SSDs, CLCD, matrix keypad, analog inputs are the peripherals found on the PIC SimLab. So we will talk a little bit about the LEDs. A LED works just like a diode and has a low energy consumption, long life, smaller size, faster switching, which make it usable in wide application fields, like as you are seeing. So in our diagram, we are having a LED which is being forward biased. It is being forward biased, meaning the positive side is connected to the positive side, that is the VDD. Then we have here the negative side connected to the ground. So we have the digital keypads also. In the digital keypad, they are based on the tactile switches most of the time, and we have two types of tactile switches. We have the pull-up. In the pull-up, we have the switch states, the signal. So the switch states determine the signal. If open, we get 1. If closed, we get 0. Pull down. If for the switch states, if open, we get 0. If closed, we get 1. We have some types of triggering methods in a tactile switch, which is the pull-up. So that's the types of tactile switch that we use in our projects. That's the pull-up. We have the level triggering, then the edge triggering. In the level triggering, actions are performed multiple times when the key is pressed. For the edge triggering, action is performed only once. Matrix keypad. Matrix keypad is the interconnection of multiple tactile keys to form a matrix. So these keys are tactile keys that are connected. They are arranged into a matrix form. So as you are seeing here, these are the column parts. Then this is the row parts. This row part is connected to the D ports. We have 4 pins. The first 4 pins connected to the D part. Then the first 3 pins of the B port B is connected to the column parts. So to detect a key press, normally the corresponding row is 0. Then when the key is pressed, it makes the corresponding column to be 0, which helps us to detect the key pressed. And through this, we were able to construct our matrix keypad function, which helps and aided us also later in our project implementation. We also have this peripheral, which is called timers and interrupts. Timers, interrupt is a signal or event that interfere with the normal flow of microcontroller or microprocessors program execution to handle a specific task or event. Normally, for an interrupt, the instruction of the main loop continues till when the interrupt is called and activated. Then the control gets out from the instruction, goes to the interrupt handler. Then the instructions in the interrupt handler is executed. Then after it is finished, it returns back and continues from where it stopped. That's, as you are seeing in the picture, it continued from I+1. That is the position of the next instruction that follows. So timer, talking about timer is a special type of interrupt. And the timer is a special type of interrupt used for measuring time. We can talk about terms of timers like the resolution, that is the width of a timer. We have the 8 bits for our projects. Our timer is the 8 bits. And for an 8-bit timer, we have 255 ticks because it ranges from 0 to 2 raised to the power 8 minus 1. So we will get 255 ticks. And a tick is from 0, like a tick denotes from 0 to 1 for every control cycle. We have 255 ticks. Then FOSC is the frequency of oscillation. We have also overflow. That is when we reach 255, then we want to go, the control wants to go enter 0. We have these methods of delay. We have the pre-scaling, then the post-scaling. Then we go to CLCD. CLCD is the character liquid crystal display. Character liquid crystal display is used to display ASCII characters. Some customized symbols possible. We have 2 communication modes, that is the 8-bit mode and the 4-bit mode. As you can see here, we have these RD0 to RD7, that is our data line. Then the other peripherals follows. So this is the schematic diagram for our CLCD, which was implemented, but actually we had 4 lines, not 2 lines, as you are seeing here. So normally a CLCD has 16 lines, as you are seeing here. So this is the real picture of the simulator that we use. I'm talking about the CLCD. We have 4 lines, as you are seeing. Then our oscillating frequency was 20 megahertz, as you are seeing here. So we will go switch into the simulation of our project. So we use the MP Lab XID for writing our projects. Then from here, after building, we got the directory of our file. So from that place, we come to our Pixim Lab, then we load our file here. So here is the directory. So we have our directory, then we load our project here. So then here's our project. So if I click number 1, that is the first option we have here. I set my timer here. Then I press enter. So here it is going. If I press 4, it is incremented the number of seconds to 30. And if I press 5, it is paused. If I press 4, it is resumed. I press 6, then it stopped. Gray also is like that. When you press 2, it goes to the set timer. I press 2, then I press enter, then it starts time up. Since my time is up, I go to gray, I go to conversion. Then also I press 3, I press my temperature, then it goes just like that. So this is the preheating. So then I set my time. I can clear. I can set it. Then I can press enter. Then it enter. I press stop, it stop. I press start here. Then it starts automatically at 30 seconds. And guys, that's our project. Thank you very much. My name is Prince Marfo.